Human memory. Psychologists believe that there are several storages. We have sensory register in our memory system, short-term memory, and then long-term memory. Now, environmental input, there are lots of a huge number of stimuli impinging on our senses. Okay, and of course here there are numerous items. So how do we process them? We can only process a very small amount of items impinging on our senses, right? So all those we don't pay attention to, they are lost because decay here is very fast. Okay? Short-term memory, the input very fast, of course, from sensory from sensory register. This is sensory register, okay? And here, through attention, we keep those stimuli here, and then when we attend to them through attention, we process that to short-term memory, okay, which has a very limited capacity. And if we do rehearsal and do organization, elaboration on the information, we can process the item to long-term memory. Sometimes we call it learn. Okay, we learn for whatever we have learned is supposed to be here, long-term memory. Right. So let's take a look at a summary here. Okay, short-term memory very fast, right? And then it is the processing is fast, and also decay is fast. The capacity limited. Okay, it's very limited, as you will see later on. George Miller, an distinguished psychologist and an excellent writer. Okay, he back in I believe if I remember correctly, in 1956, okay, he wrote a very important paper. Okay, so we know the capacity of short-term memory. It is brief, 20 to 30 seconds. If we don't do rehearsal, information in here will be lost. Okay, content, words, images, ideas, okay? Sentences, sound, and so on. Okay, retrieval, immediate retrieval. Okay? You can't wait because information will be lost from short-term memory after 20 to 30 seconds. Long-term memory is very slow because information from here. If we want to process the information in short-term memory, process them into long-term memory, it takes time. So it is a very slow process. Capacity, practically unlimited. Duration, practically unlimited theoretically. All right? So content, lots of stuff here, like everything, okay? Propositional networks, schematic production episodes, images, all the meanings, everything, okay? Like a library. And retrieval, it depends on representation and organization. Okay, we'll talk about this, right? Now, we want a lot of time when we discuss memory, we talk about information processing. What is that? Let's take a look at the executive control processes in an information processing system. Information coming into sensory memory, okay, and then into sensory memory. And then we need to pay attention, okay. When we perceive an item, say through perception, it will be processed in the short-term memory, also called working memory. Okay, the capacity, as you see here, capacity is quite limited. Then with what rehearsal, with elaboration, organization, we learn those items or we save them into long-term memory. Okay, so that's the executive control processes. And retrieval, we have to activate what we call the memory traces. Okay, we will discuss this point later on. So the activation of what memory traces, right? So this one is temporary. This one is what permanent. Okay, permanent. All right. So let's take a look at the properties of sensory register. Sensory register, you see in the environment, thousands of stimuli on impinging on our senses. Okay? It's not possible for us to process all of them. We will have to what? Because what all those materials, they are what? The sensory register maintain raw unprocessed information if we pay attention to what? To those information. All right. Now, raw, what do we mean by this here? Iconic memory. Iconic, say an image, okay, an image, which is what? Which lasts about a quarter of a second in the sensory register, after which it's gone. Okay, so therefore we have to pay attention to the what? To the items in what coming in from the environment. Okay? If we pay attention, then it will stay what in our what sensory register. Okay, for iconic memory, very short. Okay, like after a quarter of a second, it's gone if we don't pay attention to it. Echoic memory a bit longer, 4 seconds. All right, 4 seconds. Okay, after which decay occurs. All right. So let's take a look at Broadbent, Ed Broadbent's bottleneck theory. So that's what experiments on what attention. Okay, on attention. Let's take a look at what shadowing experiment. Shadowing experiment, subject what put on the stereo headphone, and then what messages what were read into 1 year. Okay, message what read into 1 year, 1 year, and then what? And then the other year, say let's say messages were read into the right ear, okay, and nothing in the left ear. All right, nothing in the left ear. Now, subjects are told to pay attention just to the right ear, all the information coming into the right ear. So that good subject could remember all those messages coming into the right ear. But the interesting thing is that when the message, when subjects also receive what messages in the left ear, the subject could do that shadow. It means what? Ignore all those coming in to the left ear and keep on paying attention to the right ear. So the subject could remember all those messages in what coming into the right ear. Okay, even though in the left ear the message changed from English to German, and the subject most subjects, they were not aware of it, that changed to German, changed to Chinese. Okay, because they did not pay attention, so they were not aware of the change. Okay, so that's called a shadowing experiment to prove that there is something called bottleneck in our attention. See here, I have a document camera, okay, to mimic or could replace a whiteboard, okay? We have what information coming in here, okay? This is what this is the sensory register, right? Now, in the environment, there are numerous stimuli coming in, okay? Coming in. And we cannot process them all, okay? So the best thing we could do is what this is like here, okay? All of them, they vie for our attention. So, see, this is what and I don't draw well, okay? This is the bottleneck. Okay, so we can only process a very limited number of stimuli coming from the environment. Okay, so our attention here hit the bottleneck. So if we pay attention to the right ear, whatever's going on in the left ear, we ignore it. Okay, and we are able to do that. Okay, we're human being, we are able to do that. Okay, so even if the message was changed from English to German, subjects were not aware of it. However, one exception: if the subject's name was called out in the left ear, okay, the subject will recognize it at once. You call my name, okay? That type of thing. Anyway, so it is not pure shadowing, okay? Not pure shadowing. And of course here, encoding occurs here, all right? When we pay attention, we encode the information, okay, into the sensory register, all right? Now, for what? For iconic memory is only a quarter of a second. We will have to pay attention to it again and again so that it stays there, right? All right, so level of processing, Craig and Lockhart, 1972. It is what? It is, they call it earth-shaking paper in memory, right? In memory. It is what? It makes a lot of sense, okay? Incidentally, Craig, okay, Gus Craig, he was my fourth year thesis supervisor at the U of T, University of Toronto, and we published a paper together, okay, back in a long time ago. Okay, that's my fourth year thesis. Okay, we published the paper together. Anyway, level of processing. Okay, what is it? Okay, let's take a look here. It is there are a lot of studies on level of processing, of course, including Peter Charles. Okay, my fourth year thesis is on level of processing. So what is it? Okay, let's take a look here. Now, let's say we have something like this here. All right. So this is memory. Okay, say number of words recalled, right? And then we have what here? We were subjects were asked to process what it's called structural process, and process the structure of the incoming information. Then here the structural, phonemic attribute of the incoming information. Here, semantic. All right. So let me give you an idea. Okay. Let's say what? Hold on. I have something here. Okay. Let me give you some examples. Structural aspect of the incoming information. All right. So let's see what here. For example, the stimulus is what? Okay, the word dog. And the question for the subject will be what? Is the word in uppercase or lowercase? So that's what the structural condition. In the phonemic condition, the orienting question would be what? Does the word, does this word here rhyme with rock, with the word rock? So this question here is to what? It is to somehow induce the subject, the process, the phonemic attribute of the word, okay? Dog, rock, right? Something like this, okay? If I was say dog, and then fog, right? So that's the phonemic what? Processing, right? Phonemic processing. All right, so it is what? Well, let me talk about what the semantic processing here, okay? Semantic processing. The question, the orienting question is that, is dog, let's say dog, okay? And the question of, is dog an animal? So here the subject would have to process the meaning of the word dog. Remember, it's alphabetic language. Okay, we don't see the meaning in the arrangement of alphabets here, DOG. Okay, we don't see the meaning. Okay, but anyway, the orientation question kind of propels the subject to process the meaning of the word. So this is called semantic processing, phonemic processing, structural processing. All right? Now, so the result looks like this. Okay? All right? Structural processing here, our memory for those words, okay, after structural processing, very poor. Phonemic, significantly better than was structural, but semantic, even better, okay, even better. That's called level of processing, right? So that is to say, the semantic aspect, okay, the semantic attribute of the word, okay, allows us to process what? Process it, we call it a deeper into the memory, okay? This one medium, this one shallow, okay? So Dr. Craig, he mentioned it like this. This is the deeper processing, intermediate, this one is shallow. Okay, all right, so that's good. Now, for those of you who are interested, Alan Pavio in University of Western Ontario, his result is that imagery is even better, right? Imagery better. That's to say, we have much better memory for pictures, okay? For pictures, okay? So That's why what we call it a picture is more than 1,000 words. Okay, we see a picture has so many attributes. Once we process the picture, we could what? We could memorize the picture. All right, so at level of processing. All right, now older children do better than younger children in what focusing and controlling their attentional process. All right? So that's what that true younger children could do that. Okay, could do that much better than what than younger children. Right? Attending the relevant cues and ignoring the irrelevant. For example, remember what? Remember Piaget's experiment, right? Older children could process what? Could process the like what? Process what the size, okay, the distance, okay, the what? The size of it, the distance of it, the shape, the texture, and so on. Younger children, they don't have this ability to do that. Okay, so using multiple encoding. Can they attend to relevant cues? For example, remember Piaget's conservation experiment? Younger child will only pay attention to the height of the cylinder, okay, and then ignore the diameter of the container, right? So would point the finger to the tall cylinder. More water here, okay, even though it's the same amount of water poured into the tall cylinder. All right, and older children could encode all these here different attributes of the incoming information. Younger children perhaps can only process the size. Okay, all right. Processing information faster. Well, that's due to maturity, right? Due to maturity, and it is a matter of maturity and of course of experience, right? Of experience. So take a look here, okay? This is short-term memory, also called the working memory. Okay, also called the working memory. And information coming in here, and then if not attended to, okay, or if not rehearsed, okay, decay or forgetting occurs very rapidly. Okay. However, there is a thing called interference here. They interfere with whatever we attend to. That interference will cause forgetting, right? And once information is stored in long-term memory, okay, so retrieval, it is possible, okay. Now, elaborative rehearsal means what? On the basis of whatever we have here or whatever we have here, we elaborate on the existing stimulus or existing information here, okay? We draw something from here to help us elaborate our rehearsal so that the item could be stored into the long-term memory. All right. Okay, so let's take a look at short-term memory. Short-term memory is also called the working memory or active memory. The capacity, this is George Miller's 1956, a paper called The Magical Number 7 plus or minus 2. Right? 7 plus or minus 2. Well, he argued and he wrote the paper beautifully. It is one of the best 40 papers in psychology, in the history of psychology, and you should read this paper. Beautifully written, okay, beautifully written. So our short-term memory can hold something like 7 plus or minus 2 distinct items. Okay, so they're different. Okay, now you could do this experiment very easily at home, okay, with your siblings, even with your parents. Okay, you collect say 10 coins, okay, similar, say 10, I don't know, 10 quarters. And you try to throw them in the air so very quickly. Okay, once they drop onto the floor, you cover them up with, well, I don't know, just cover them up with a cloth, okay, and ask, how many coins have I just thrown up into the air? So sometimes you throw 3, sometimes 5, sometimes 7, sometimes 10. And you repeat this experiment enough number of times, and I will tell you, definitely arrive at this here 7 plus or minus 2 items, distinct items, all right? So that's the limit of what? Of the short-term memory, or the capacity of the short-term memory, okay? So that is to say, we could only pay attention to no more than 7 to 9 different items in our working memory. Okay, and of course there are variabilities among people. Some could only hold 5, some 7, some even 9. Okay, but then in general, we know is 7 plus or minus 2 distinct items. Okay, now then you may ask, how could we enlarge the capacity? Well, through chunking. So what is chunking? Chunking means what? You put, let's say here, okay, let's say here, okay, 1, 2, 3, 4, 5, 6, 7 items here. Okay, 7 different 7 numbers. Okay, here. Now, how could we memorize all of them here? For example, these numbers are actually 474341 is actually my number. Okay, at Nipissing. Okay, my number at Nipissing. Now, if we want to memorize all of them here, there are 7 items. Very difficult for us to memorize all of them. But then if we chunk them, say 474 is 1 unit, this is another unit, then it would be a lot easier. So we process 747 as 1 item, 3461 as another item. So we only process 2 items instead of 7 different items. Right, that's called chunking. And now you understand why our phone number is something like this. Let's say it was 705 here. Here, why this? Well, that's to help us chunk information. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. Okay, to memorize 10 different numbers, very difficult. But then if we put them into only 3 chunks, it's easy, a lot easier to do that. Okay, try it out. Okay, so that's why the dash here. Okay, it is because of chunking. Okay, now take a look here. Holy cow, how can you memorize this here? But then if you break it up into what? Well, you process what here? You process the semantic aspect of these strings of characters, right? Not the phonemic. You could do that too. See here. HA, haha, too much sex make you short-sighted, right? This one appears in a textbook. So many characters, so many characters here. We can memorize it because what? And when we put them together, then this one here, it makes sense. So we process the semantic aspect, right? Or maybe the phonemic aspect. This is considered as one item. See what I mean? That's the one. Through chunking, we could increase the capacity of short-term memory. All right. Now rehearsal. Rehearsal means what? Keeping the materials in short-term memory. So we rehearse 474 3461 474 3461. I remember my own number. Okay, that's rehearsal. And what? Then sometimes when we attach, for example, we have HATOO, and all that here. And after elaboration or organization of some sort, we'll be able to process the information into long-term memory. Okay, so this is elaboration or organization. We organize them in this way. For example, if we are presented with TOO first, and then SEX, and then YOU, and then SHORT, and then HA, different items. Okay, it is hard for us to remember, but if we organize them into this fashion, we'll be able to process information to the long-term memory. Repetition effect. Now, rehearsal. You rehearse, but then what is repetition effect? Okay, it is called the study phase retrieval. Okay, this is Peter Child's master's thesis. Okay, now let's say here. Okay, let's say here, we have present words. Okay, the word here. Hold on. A word here, learn the word here, different words, okay, different words here. Now, if a word appears twice, the likelihood is good that we'll be able to memorize this word, okay? Well, let's say this word appeared twice, okay? Yeah, this is the first time, and this is the second time. This is the first time the word appears, then this is the second time. So this is the repetition, right? Repetition. So in general, we want the more number of times the word reappear, the better will be our memory for the word. Okay. Now, of course, here this is true. But then study phase retrieval means what? So this is the first time the word appears. Okay, good. Then another word, another word. Then the second time it appears, then what? If the subject realizes that, I have seen it here. This is the second time it occurs. So if this happens, if the subject recognizes that this is the second time the word appears, then this word will be better remembered than those words that occurred the second time. Let's see, there's another word here, okay? This is the first time, this is the second time, but the subject here does not recall that this word This word is the second time it occurs. So there is no study phase retrieval. Then the likelihood is that this word won't be memorized. Okay, so this is called the repetition effect study phase retrieval. Of course, level of processing in short-term memory. Okay, in short-term memory. Now, level of processing also occurs in sensory register, but then a lot of time it is too fast. Okay? Too fast for us to do that. So most of the time, level of processing occurs in the short-term memory, right? Short-term memory. All right, retrieval based on phonemic or structural attributes, okay, in short-term memory, because it is in the short-term memory. If in the short-term memory we could afford semantic processing, then that item is likely to be in the long-term memory. All right, so retrieval from short-term memory is likely to be the phonemic aspect of the information, or the structural aspect, or we call it the structural attributes of the information. Okay, all right. Remember, there is interference. There is interference when we try to recall, like retrieve information. We have proactive interference and retroactive interference. So what is proactive interference? Okay? Now, proactive interference, it is forward. Okay, let's take a look. Learn A, and then you learn B. Okay, and you try to recall B, but then what you have learned here A will interfere with your recall of B. So this is called proactive interference. So the forward interference. Learning A. Okay, and then you learn A, learn B, but then learning A will interfere with your recall of B. Okay, this is forward interference. Retroactive interference, backward. Let's take a look. Learn A, learn B, and then you try to recall A, but then But then B, no, I'm sorry, here, learn A, you learn B, and you try to recall A. Okay, try to recall A, but then But B will interfere with your recall of A. Right? Okay, so the process of storing information or learning can disrupt both past and future learning. Okay, past will be retroactive interference, future proactive interference. Okay, now forgetting in short-term memory is very useful. Peter, why do you say this? Well, 7 plus or minus 2. Remember this here? In our short-term memory, we only hold 7 plus or minus 2 items. Okay, now forgetting in short-term memory, it is very useful because once you forget, then then it becomes, let's say you forget all 7, then then you have capacity for more items. Is that right? For more items. And also, when you forget, if you cannot forget those items, if they stay, how can you process new information? You cannot, because the capacity is only 7 plus or minus 2, about 5 to 9 items. Okay, if you don't forget or you don't get rid of them, new information cannot come in. Right? So in this sense, forgetting in short-term memory, it is very useful. Okay, because it opens up space for new information to come in. All right, so take a look at this here. So this is our short-term memory, and this is our long-term memory. We have interference, okay, forgotten or misplaced, and we will talk about this here when we come to long-term memory. So long-term memory, the forgetting is called decay, okay? It's just because what we don't gain access to it after a long time, okay? Retrieval is that we may have to reconstruct the information or through what? Through elaboration, organization, okay, or through contact, and we will what? Discuss all this later on, all right? Now, long-term memory, it is what? It is quite what? It is fascinating, is that right? So I think I'll do it here, but then I will bring this up again later on. Okay, let's say here, from here to here, that is actually what has happened. Okay, an incident. Let's say we process this into long-term memory, okay? But then on retrieval, we think we remember everything, but in fact, we don't we should do this. We don't remember this. We don't remember this. We have lost memory of this. But then the thing is that we are not even aware of our forgetting. Okay, we tend to do this here. Okay, we fill in the gap. We fill in the gap. The best we can. However, a lot of time we fill that in according to stereotypes, according to our biases, and so on. Okay, and so on, and that's why the court of law recognizes this. Okay, therefore, here someone has to be grilled by the defendant lawyer, and also by the other side's lawyer, and so on. Okay, just to make sure, that the person is telling the truth. All right, good. Let's move on. Long-term memory. Long-term memory, look at the characteristics here, more passive than short-term memory. Yes, it is passive, unconscious. Okay, we don't even know that we have so much stored in our long-term memory, and not easily disrupted. For example, proactive, retroactive interference. Okay, no, not that easily disrupted. Partly generative rather than reproductive. Now, remember this here? We think we reproduce the whole thing, but now we actually we generate this according to our biases, according to our upbringing, according to according to stereotypes. So we reconstruct long-term memory. Okay, we don't reproduce. Okay, because we can't do that. Okay, but then we reconstruct this, fill in the gaps here without without us being aware of the fact that we are doing this. So a lot of time we fill in the gap incorrectly. Okay, so that's one of the characteristics of long-term memory. Okay, partly generative rather than reproductive. unlimited capacity. So far, what it is, we consider it to be what? Unlimited. Okay? Forgetting in long-term memory is almost non-existent. Okay? It's almost non-existent. All right? Encoding in long-term memory, it is likely to be what? Pictures, okay? Visual images, okay? Visual images, or verbal representations, or elaborations, that is to say, the semantic aspect of the information. All right, in long-term memory, Endel Tophing, that is authoritative figure in memory, together with Craig, a authoritative figure. And when I was at U of T, Endel Tophing was the department chair. Okay? I met him in person twice, I believe. Okay. Anyway, so he's from Harvard. Okay, Tophing from Harvard. All right, so episodic memory is like the conveyor belt system. Okay, let's say you see something, it's just like you put a plate on a conveyor belt, it moves away from you. So, this is whatever items we have in the memory, it is the moment you register it, you encode it, and it is moving away from you. That's called episodic memory. Okay, so that's to say sometimes you have to look at say that it has the attribute of time and place, right? So the context, okay, sometimes the time, place, the context, they are also included in the memory. Okay, so these may, especially time, is that right? And if you try to remember, last night, what is it that I do? Okay, that type of thing. Okay, so that's episodic memory. All right, now organizational memory. So Tophing was stipulated that mostly organizational memory is mostly semantic in nature. For example, knowledge base, conceptual framework, and so on. Right. So these are the a result of organizational memory, and then the semantic meaning will help with processing information into the long-term memory, right? So later on we see knowledge here, the structure of knowledge. Okay, we have a lot of associations in the long-term memory through an organizational network. Retrieval is based on visual or semantic attributes of the encoded material. Right? That's the depending the mostly visual, because imagery, we might look at imagery here, stays a lot longer, okay, in our memory than the other attributes. Anyway, so retrieval based on visual or semantic attributes of the encoded material. All right, now aids for retrieval. What is that here? Aids for retrieval. Overlearning. Overlearning means what? Means you learn it to the stage where you can memorize everything. So that's overlearning. Remember, I asked the class to overlearn the 7 secondary cues in test wiseness. Okay, it will do you a lot of good. And the second one is understanding. Of course, understanding how can you get understanding? Well, after organization of some sort, is that right? You want understand the meaning and what you elaborate on a lot of stuff so that what after organization you learn it, and that's understanding. And of course, building an organized knowledge base, relating new material to the existing knowledge base or to the existing knowledge structure, right? So this kind of organization is called what? Elaboration. Okay. Now use what relevant what cue association. Okay. Now for example, later on we'll talk about it here. If you want, remember what, if you remember the context, okay, the context will help you to what, retrieve the material. If you remember the time or the color of the dress, okay, the what, the sun is setting, that type of thing. Okay, you use what? Relevant cue association. Using mnemonics, which are systematic procedures for improving one's memory. Many of these mnemonic strategies use imagery, okay? Because what? Imagery is powerful. Say imagery here, remember? It is very effective in what? In helping us to what? Memorize. All right, take a look at what? Take a look at what? The what? Mnemonic strategies, for example, rhymes, patterns, acronyms, that type of thing. Take a look at the what? The loci method. Now, here is that what you imagine a very familiar place, such as your own home, okay, and pick out particular locations. These locations serve as pegs, P-E-G-S, to hang memories. I'll give you an example. Okay, remember to buy ice cream, butter, and milk. Ice cream, butter, and milk. How best to remember this? Now you're young, of course, you can remember what these three items are among a string of other items, but then these are most important. Okay? Your mother said, "You bring what? You bring me this. You bring me ice cream, butter, or milk, or you don't come back." You have to memorize them, right? So using what? Using loci method, you do this here. You imagine the soap dish in your bathroom is holding the butter. Isn't it bizarre? Yes. And what? The more bizarre it is, the easier for you to remember because it is unusual, is that right? You don't easily get confused or get interfered by other things. And the bathtub, imagine the bathtub is filled with milk. And the basin sink stands an ice cream block. That type of thing, okay? So that's called the loci method, all right? So other pack type mnemonics use a standard list of words. For example, 1 for Peter, 2 for Paul, something like that. But don't rob Peter to pay for Paul, okay? All right, so that the one. Another one, pack type. And use acronyms. I use acronyms. Say what? You use IBM for ice cream, butter, and milk. All right? So that's easy. Okay, that's easy. I use IBM. But just don't make the mistake of forgetting what the letters stand for. Okay? And inadvertently, you bring home what? Instant coffee, bananas, and margarine. Oh, your mother will be angry. You die. You die. All right. And remember, remember even from a radio station and in a lot of textbooks, Holmes, Homes, for the 5 Great Lakes in North America, Lake Huron, Lake Ontario, Lake Michigan, Lake Erie, and Lake Superior. Right? A big Lake Superior. Well, I think Thunder Bay is right there. Okay. All right. So that's good. Link system, or also called chain mnemonics. Here, each item in the list is linked to the next through some visual association or through a story or a storyline. For example, to remember these words here, okay? Elephant, credit, purchase, bar. So these 4 words, they are unrelated, is that right? Well, I'm only giving you say 4 words, okay? So, of course, sometimes let's say 9 words, okay? You do the following. You imagine the elephant used the credit card to purchase a bar of chocolate, all right? Then, if you do this here, you are likely to remember the words, elephant, credit, purchase, and bar, right? So this is called the link system, also called chain mnemonics. That is to say, you chain them up together. Okay? Phonetic or keyword method. What is it here? Well, phonetic, it means it sounds like. Okay, you use familiar English word, okay, to use the sound to learn a foreign language. A lot of time you do that. Okay, so Peter Chow did that when I first learned English. Now, the word carta, C-A-R-T-A, it is a Spanish word which means letter. Okay, letter. You receive a letter from your loved one. Okay, so carta in Spanish means letter. It sounds like English cart, C-A-R-T. Okay, so cart becomes the keyword. You can imagine a shopping cart filled with letters on its way to the post office. By doing this here, you're likely to remember the Spanish word carta means letter. Right? Okay, so that phonetic or keyword method. The last one here, vivid visual image, can be unusual images. Well, if it is unusual, you are likely to remember it. Is that right? So IBM, ice cream, buttermilk. Remember this? Okay, your mother asked you to bring them home. Okay, so you imagine a vivid visual image of a gigantic ice cream cone soaking in milk and surrounded with slices of bread with a lot of butter on them. That kind of thing, right? So you create a bizarre image, okay, or a bizarre picture, right? So we just mentioned type of memory. We have episodic memory, okay? Like a conveyor belt, okay? Like a conveyor belt, okay? Now, when you are at school, when you're doing gymnastics practice, all that here, that they form episodic memory, is that right? So you remember what you have done, that type of thing. When did you do that? Semantic memory is is like a library system. Okay, and then procedural memory, like how do you use the computer, right? That type of thing. I will elaborate on this with another one overhead. Okay, so take a look at this one here. Okay, now, long-term memory consists of what? Consists of decorative knowledge, consists of procedural knowledge. Okay, so there are two types here, in that the contents of long-term memory, and of course the decorative memory here, and then as opposed to procedural memory. So let's take a look at what in decorative memory we have semantic memory, episodic memory. Okay, let's take a look at semantic language. Okay, it is a memory for meaning. You know that. Okay, it's a memory for meaning. Now, these memories are stored as propositions. Okay, images, propositional network images, and schemas. Okay, schemas. Here we have we have a story grammar, or we have a script or event schema. So let's take a look at this here. Okay, propositions and propositional networks. A proposition is the smallest unit of information that can be judged true or false. Right? So that's easy. Okay? It is like an atom, right? The smallest unit of information that can be judged true or false. So propositional network is interconnected bits of information. For example, I'll give an example. Okay, Mary was driving an exotic sports car. Now, Mary was driving an exotic sports car. In this sentence, it has two propositions. The first one is Mary was driving a car. The second proposition is the car was an exotic sports car. I like to own an exotic sports car, but I don't have the money. Anyway, when we want to recall a bit of information, we may translate its meaning as represented in the propositional network into familiar phrases and sentences or mental pictures, images. Okay. Also, because of the network, recall of one bit of information can trigger or activate recall of another. Right? We are likely not aware of these networks, or they are not part of our conscious memory. Okay, for example, you've been attending classes in one of those classrooms, let's say big classrooms at Nipissing. Okay, let's say your first year psychology. Okay, now, do you still remember how many lights are there in that room? Okay, so when I ask you this question, most of you are likely to call up an image of the roof of the room, the ceiling of the room, in your mind's eyes. Is that right? And you could count how many lights are there. That type of thing. All right? That type of thing. So you are not conscious that it is in your memory, but you could do that. You could do that, right? So that the propositional network. Okay, images are representation based on what perceptions. So images mirror what they represent. Okay, they preserve the physical attributes and spatial structure of information. Okay, so images are what? They are useful in making many practical decisions, such as what? How a sofa may look in your living room. Okay, before you move into a new apartment, okay, you visit the apartment, then you go to where is it? Where would you like to go? To Leon, okay? Leon. Okay. You look at the sofa and say, gee, could this fit in my living room? Okay, so you will have the draw up image of your new living room. Then what? You just put the chair there. Okay, of course, here you are using mental power to do that. Okay, it is of course images it is quite abstract. Is that right? It's quite abstract. All right. So shimmer, also called schemata. Okay, schemata. Okay, they are abstract data structures that organize vast amounts of information. Okay, a schema is a pattern or guide for understanding an event, a concept, or even a skill. Okay. Now, the schema tells you what features are typical of a category, what to expect. The schema is like a prototype or like a pattern specifying the standard relationship in an object or situation. Let me give you this example. General people's schema of an automobile is much less richly developed than the schema of a car designing engineer. Is that right? Right? So when a car designing engineer looks at a vehicle, looks at a car, okay, the schema or the image they got is quite different from ours, okay, layman, right? That type of thing. So you know what that means, okay? You know what that means. Now, here, let's take a look at what the story grammar, okay? Story grammar. What is that here? A story grammar. Sometimes called a schema for text or a schema for story. A schema for on what? Structure. Okay? So here, story grammar helps Helps students to understand and remember stories. Okay? Okay, now take a look here. To comprehend a story, we select a schema that seems appropriate. Then, even when you watch television, okay, you watch CSI, you do that, okay, quite unconsciously, okay. Then we use this framework to decide which details are important, what information to seek, and what to remember. The schema guides us in interrogating the text, okay? Filling in the specific information we expect to find so that the story makes sense, right? Now, without the appropriate schema, trying to understand a story, trying to understand a textbook or a classroom lesson is a very slow, difficult process. Something like finding your way through a new town without a map, right? So that is called a story grammar. Let me give you an example, then I will come back to this script or event schema. Now, schema for the word bison. Take a look here. Okay, you have what here? Animals. And while Native Americans is something what associated with this. The animal, non-animals, non-mammals, mammals. So mammals, bison is considered categorized as what? Mammals. Okay, so you have bison, and here it is a large woolly brown, has short horns and so on. Okay, and they feed on grass, and they travel in large herds. Okay, what are their use of meat and hide? Okay, they were once heavily hunted and on the brink of extinction. Okay, so bison. Okay, bison. Now, have you seen one? Have you seen the movie by Kevin Costner? What is it called? Crying with Wolf. Something like this. Okay, that there is a scene of of the native and Kevin Costner hunting for bison. Okay, the bison, a herd of bison moving very quickly. Okay, anyway, so that's bison. All right, so the concept bison, for example, falls under the more general concept of mammals and animals, and is related to many other ideas that help differentiate it from other concepts in memories. For example, here is another associated concept, okay, for us to understand bison. Let's take a look at this is schema. Okay, take a look at story grammar. Let's read this story. See if we understand it. If the balloons popped, the sound wouldn't be able to carry since everything would be too far away from the correct flow. A closed window would also prevent the sound from carrying, since most buildings tend to be well insulated. Since the whole operation depends on the steady flow of electricity, a break in the middle of the wire would also cause problems. Of course, the fellow could shout, but the human voice is not loud enough to carry that far. An additional problem is that a string could break on the instrument. Then there would be no accompaniment to the message. It is clear that the best situation would involve less distance. Then there would be fewer potential problems. With face-to-face contact, the least number of things could go wrong. You will find that in this paper, right? Let's take a look here. Does it mean anything to you? Hardly, is that right? But then, if you have a story grammar, look at this. Does it make sense? Have you done anything like this before? All right, so that's story grammar. Okay, and we actually do this very often when we watch movies. We constantly change the story grammar so that we understand we think we understand what the movie or we understand the program. All right? So this is good. Is that right? All right. Let's take a look at here. What is this? A script or event schema. All right. This is a schema representing the typical sequence of events in an everyday situation. Okay, it is called script or event schema. Children as young as 3 have basic scripts for the familiar events in their life. Okay, and another example, even a dog, okay, has this kind of event schema or script. A dog will nudge you into taking it out for a walk in the evening. All right, so that is that is very basic, okay, of animals and human being, right? So this is how we live our life, right? Okay, good. Now let's take a look at episodic memory. Okay, so let's take a look at where is that? Here. Episodic memory. Okay, we have done semantic. Okay, episodic memory. Remember, it's like a conveyor belt analogy, right? Conveyor belt analogy. So memory for information tied to a particular place and time, and especially information about the events of your own life. Okay, now not just the place and time. That means the context. Okay, in which that thing took place. Okay, so and then here episodic memory keeps track of the order of things. All right, in a conveyor belt. Okay, whatever things happened last night is in the conveyor belt is far away from you now. Is that right? At this time, when you're listening to this here, the long-term memory stuff is already far from you. Is that right? Okay, all right. So, episodic memory and semantic memory, they are quite different. The two memories are different. Let's take a look here, okay? One researcher put it this way: semantic memory contains the basic elements of knowledge, and episodic memory is made up from these elements. Good. Semantic memory is like a dictionary containing the meanings of all of the words and images you know. Episodic memory is like a novel or a movie that puts these concepts together in particular ways. All right? Good. Yeah. All right. Sure. Let's take a look at procedural memory. So memory for how to do things is called procedural memory, right? So procedural memories are represented as condition action rules, sometimes called productions, procedure, production. So production specifies what to do under certain conditions. People cannot necessarily state all their condition action rules, but they act on them nevertheless. Okay, the more practiced the procedure, the more automatic the action. All right. Now, like driving a car, say driving a standard shift car. Okay. You have to shift gear, first gear, the second gear, then you have to coordinate that shifting with footwork on the clutch. I bet most of you don't know how to do that. Is that right? Well, statistics have informed what Peter Chow that at this point in time in North America, no more than 10% of the people know how to drive a standard shift vehicle. Okay, I bet most of you have automatic transmission. Is that right? Right. I hate automatic transmission. I have a standard shift, 6 forward gears, 1 backward, okay, and it is fast. Okay. Anyway, Peter Chow likes fast cars. Okay. Anyway, I drive very carefully. By the way, all right. So, procedural memory, of course, it's heavily influenced by what? Heavily influenced by lack of sleep. Okay? If you are lack of sleep now, here, skills. Okay? Skills is what skills are considered to be collections of procedural memories, habits. Okay, you get up, you do this, you do that, you follow the procedure, right? So these are what procedural memories. All right. Okay. Now we have we have this here. Case. We will come back to this in our next video. Right? Good. Thank you.